Dear viewers, today I will teach you composition of functions. How we can compose two or more functions to form a single function. टू से ज़्यादा फंक्शन कंपोज होके सिंगल फॉर्म कैसे करते हैं, और दैट फंक्शन इज नोन एज कंपोजिशन ऑफ फंक्शंस. लुक एट हियर, this is x set and this is y set, this is z set. F is a function from x to y, f is a function from x to y, g is a function from y to z. If f is a function from x to y, then we can write, तो हम क्या लिख सकते हैं, f of x is equal to y. So f of x is equal to y means y is equal to f of x. So x is related with y. This set is the range of f. This is range of f. That means this is f of x set, and here this is the range of g. That means this is g of domain of g is y. So this is g of y. Now look at here. G is a function from y to z. If g is a function from y to z, like f is a function from x to y, f of x is equal to y. G is a function from y to z. So we can write, हम लिख सकते हैं g of y set का एलिमेंट y is equal to z. Now look at here how we can form a composition function. In order to form composition function, look at here, we have z is equal to g of y, which is equal to g of, but y is equal to f of x. So this is g of f of x. ये g of f of x, so हम इसे लिख सकते हैं g of f of x. So we find z is equal to g of f of x. Now this is one function, is known as GOF, g of f. That means this function is composed of two functions f and g. If f and g two functions exist, अगर two functions f and g exist करेंगे, तो we can compose another function with f and g, that is known as g of f. This g of f is the composition of two functions f and g. This is the composition function, is read as g of f or GOF. Look at here, when we write f of x is equal to y, y is equal to f of x, that means this is a function from x to y. ठीक से देखो, f of x is equal to y means f function है from x set to y set. So here z is equal to GOF x. This is a function. I am writing here f of x is equal to y, that means y is equal to f of x. y is equal to f of x. When y is equal to f of x, जब y is equal to f of x होता है तो ये f x से y तक फंक्शन होता है. तो look at here, z is equal to GOF x. So this GOF is a function from x to z, from x to z. That means there is a function from x set to z set. Here this function is from x to z set, and this function is known as a GOF function. So if f is a function from x set to y set, g is a function from y set to z set, then there is another function GOF which is from x set to z set. But a function GOF is composed of two functions, and this is the composition of functions. Here the domain is x. Look at here, when f is a function from x to y, the domain of f function is x, co-domain is y, and the range of f is this set. Domain of g is y set, and domain range of g is this set. Co-domain of g is z set. So f is a function from x to y. This is domain of f, this is co-domain. So if GOF is a function from x to z, I write here GOF is a function from x to z. GOF is a function from x to z. So I write GOF is a function from x to z. If GOF is a function from x to z, then domain of GOF function is x set, and co-domain of GOF function is z set. So this GOF is known as the composition function. If यू हैव गिवन टू फंक्शंस, अगर तुमको टू फंक्शंस दिया गया है f and g, हाउ कैन यू फाइंड गॉफ फंक्शन and when actually the composition function can exist. Look at here, this gauge function will exist. Gauge function exists if there is a condition. What the condition? Look at here, gauge is g of f. So the condition is here, this is the range of f function. Y set is a codomain, but this shaded set is the range of f, and this y is domain of g, domain of g function. This y set is the domain of g set, and this shaded set is the range of f function. G of f of x, g function can be evaluated of the value f of x. So you have to first find f of x, then you have to find the g value of f of x. So look at here, you have to find the g value, that means the g function of not all values of y but the only functions of x, that means this value. So if you want to find g of f of x, means g value of this, then this must be subset of y set, that means this. The only condition is range of f should subset of domain of g, means the y set. If f is a function from x to y, g is a function from y to z, then in this case there is a function from x set to z set, that function is gauge function, the composition function, and this composition function exists or exist करेगा when the, look at here, second जो f है, the range of f should be subset of domain of g. अगर f का range g का domain का subset नहीं हुआ तो gauge function cannot exist. If we take two functions f and g, we can find two different composition functions. Like gauge, another composition function is also f of g. This is f of g of x. But in this case we cannot find f of g. In this case हम gauge निकाल सकते, यहाँ f of g नहीं निकाल पाएंगे, क्योंकि g of means, look at here, g of f, gauge, g of f in composition function g appears first, g पहले आता है, but actually in diagram g second आता है और f first आता है. So always remind, g of f means f जहाँ खत्म होगा g वहाँ शुरू होगा. gauge means, again remind, gauge means f जहाँ end होगा, f का कोडोमेन जहाँ है, g का डोमेन वो है. So look at here, an example, x is a set 2, 3, 4, 5, y is a set 3, 4, 5, 9, and z is a set 7, 11, 15. F is a function from x set to y set, and that function is defined as 2, 3, 3, 4, 4, 5, 5, 5, and g is a function from y to z and defined as 3, 7, 4, 7, 5, 11, 9, 11. The question is, how can I find gauge function? So gauge function means the function from x to z set. This is gauge function. So in order to find gauge means g of f, first we have to find the values of f. So look at here, we want to find gauge function. So domain of gauge is x set. Domain of gauge function is x set, and the codomain of gauge is z set, because gauge is a function from x to z. gauge x से z तक जाता है, तो gauge का domain x है. So when we are evaluating a value, when we are evaluating the value of a function, we have to find the values, the elements in the domain set. So the domains, the set contains 2, 3, 4, 5. So when you want to evaluate gauge, that means you want to find gauge, you have to find the gauge of first element, is here 2. You want to find gauge 2. Then you can find gauge 3. So now gauge 2, GOP2 means g of f of 2, and this is g of f of 2. Look at here, this is f function. If this is 2, then this is f of 2. You know the elements of a function are written in this form x y. हर एक फंक्शन का एलिमेंट्स को हम एक्स वाई फॉर्म में लिखते हैं, जहाँ एक्स वाई इज इक्वल टू एफ ऑफ एक्स. तो फर्स्ट एलिमेंट एक्स होगा तो सेकेंड एलिमेंट उसका इमेज एफ ऑफ एक्स होता है. सो इफ दिस इज 2, दिस इज एफ ऑफ 2. This is the representation of a function. The first element is 2, so this is f of 2. That means g of f of 2. So this is 2, this is f of 2. So f of 2 is equal to 3. G of f of 2 is equal to 3, which implies g of 3. Look at here. You have to find the value of g of 3 from g function. And here is 3. So this is the image of g image of 3. That means this is the g of 3. So g of 3 is 7. Similarly, g of f of 3. G of f of 3 means g of 3 means g of f of 3. And this is equal to g of f of 3. F of 3 means f is here and the element 3 is here. If this is 3, then the image of 3 means this is f of 3 is 4. So we can write f of 3 is equal to 4. Then we can find g of 4. G of 4, look at here. G of 4 is here. If this is 4, then this is g function. That means this is g of 4 and g of 4 is 7. And similarly, you can find g of f of 4 and g of f of 5. So in this way, you can find g of f. And from this example, we cannot find f of g. We cannot find f of g because in order to find f of g, the first function should be g and second function should be f. Now one example, let f is a function from R to R, a real number set to real number set, defined as that function f of x is defined as f of x is equal to x plus 1. Another function is g from the set of positive real numbers R plus to R, as the function is defined as g of x is equal to root x. Find f of g and g of f to find the two composition functions. First, to find f of g. But in order to find the composition function, very important thing is how can find when the composition function can exist. Look at here, the range of second should be subset of a domain of a first. If range of second is subset of a domain of first, then we can say the composition function exists. So in order to find the composition function f of g of x, we have to test whether range of g is here, range of g is R set, and domain of f is R set. So this is subset, every set is subset of itself. So here range of g is subset of a domain of f, which implies f of g exists. So if f of g exists, so how can you find f of g? Look at here, f of g. When you want to find the composition function, first test whether it exists or not. F of g of x. F of g of x means f of g of x, which is equal to f of g of x. Look at here, f of x is x plus 1. Interesting trick, how can you find g of f of g? F of g of x, we have given f of x, and this f of g of x can be evaluated from this function. F of g of x हम निकालेंगे from the function f of x. How can you find? Look at here, here is x but here is g of x. That means you can replace x by g of x. Simply put g of x in place of x. So you can find f of g of x. How? F of x is equal to x plus 1. F of 1 is equal to 1 plus 1. F of 2 is equal to 2 plus 1. F of corona is equal to corona plus 1. F of g of x is equal to, if we put x is equal to g of x, then f of g of x is equal to g of x plus 1. So f of g of x means we can put here x is equal to x is equal to g of x. That means this is g of x plus 1, and which is equal to g of x is given is root x plus 1. So this is f of g of x. Next to find GOF. In case of g of f, first to test whether this GOF function exists or not. Look at here. In order to test whether this exists or not, the condition is range of a second. Like here, range of a second should be subset of a domain of first. That means range of second means f. Range of f should be subset of a domain of g. Range of a second should be subset of a domain of g, means first, which implies range of f. Here range of f is R, and domain of g is R plus. So this is not subset. As this is not subset, so we can say g of f does not exist. Can find f of g of x, but we cannot find g of f of x because this condition is not satisfied. Many times we are evaluating f of g and g of f without testing the existence of these composition functions. If we evaluate f of g and g of f without testing, then this will be wrong. First test, then evaluate whether the value, then evaluate the composition functions. Another example, if you change the domain and range of this example, then both f of g and g of x, both f of g and g of f exists. So if we change, how can? Let f is a function from r plus to r plus and g is a function from r plus to r plus, and f of x is equal to same, x plus 1, g of x is equal to root x. The function remains same. I simply change the domain and codomain. If I change the domain and codomain, then under this domain and codomain, you can find both f of g and g of x, because here it will be r plus, here it will be r plus. R plus is subset of r plus, so here g of x, g of f exists. Now another composition function, here f is a function from a to b, g is a function from b to c, and h is a function from c to d. If f is a function from a to b, then f of element of a set means x, f of x is equal to element of b set means y. So y is equal to f of x. Similarly, g is a function from b to c, so z is equal to g of y. H is a function from c to d, so this element t of a set d, t is equal to h of z. Now look at here, t is equal to h of z, which is equal to h of z is actually g of y, which is equal to h of g of y. Y actually f of x. This is f of x. So this is h of g of f of x. So this is a function which is h of g of f. This is composition function, and this is composed of three functions, f, g and h. Look at here, h of g of f. This is the composition function, and this composition function is from x to t. That now this composition function is a function from x is the element of a set, from a set to the element t is in d set, from a to d. So this is a function from a to d. A to d. So the function from a to d is h of g of f. This is the composition function from a to d. Here the composition function is composed of three functions, f, g, h. One example, f is a function from n to n, g is a function from n to n, h is a function from n to r. defined as f of x equal to 2x, g of y is equal to 3y plus 4, h of z is equal to sin z2. So h of g of f is equal to h of g of f. This is h of, look at here, this is g of f of x, and which is equal to h of, this is g of f of x, which is equal to h of g of f of x. F of x is 2x, which is equal to h of g of 2x. Now g of y is 3y plus 4, 2x. G of y is equal to 3y plus 4. G of y is equal to 3y plus 4. But here y is equal to 2x. Put y is equal to 2x. Now this is h of g of 2x, means put y is equal to 2x. If we put y is equal to 2x, this is 3 into y is equal to 2x plus 4, and this is h of 3 into 6x plus 4, which is equal to, we find h of 6x plus 4. Now h of z is equal to sin z, h of z is equal to sin z, h of 1 is equal to sin 1. Now z is here 6x plus 4. Put z is equal to 6x plus 4, and this is sin z. Z means z is equal to 2x plus 6x plus 4. So this is h of g of f. Now we want to find h of g of f of x. This equal to h of g of f of x, and which is equal to h of g of f of x. Here f of x is 2x, and this is h of g of 2x. Now look at here, g of y is equal to 3y plus 4, and g of 2x means put y is equal to 2x. So 3 into 2x is 6x plus 4. This is h of 6x plus 4, but h of z is equal to sin z, and put z is equal to 6x plus 4. So this will be sin 6x plus 4. So from these two we find h of g of f, h of g of f is equal to h of g of f. These two are equal. Now properties. The first property is if f, g, h are functions from R to R, means this f, g, h are three real valued functions. These are the three functions from the set of real numbers to real numbers. The first condition is the addition formula. That means f plus g of h is equal to f of h plus g of h, and second is f into g of f h is equal to f of h into g of h. Second property, composition of functions is not commutative in general. That means f of g is not equal to g of f in general, but sometimes they may be equal, and many times क्या होता है कि f of g exists, g of f doesn't exist, g of f exists, f of g doesn't exist. ये this exists, this doesn't exist. ये exist करता है, ये exist नहीं करता है. And also sometimes क्या होता है कि f of g, g of f both exists and both are equal, but many times in general the two may exist, but in general they are not equal. So that's why the composition function is not commutative. Next property is composition of functions is associative. That is h of g of f is equal to h of g of f. So look at here, f is a function from a to b. How can, now the proof is f is a function from a to b, g is a function from b to c, h is a function from c to d, f from a to b, g from b to c, and h from c to d. And the function which is from a to c is g of f. A to c means g of f. B to d means, look at here, b to c, c to d means h of g. So b to d is h of g. Now g of f is a function from a to c. G of f, g of f means a to c, h of g means b to d. Now look at here, g of f is a function from A to C and h is a function from C to D. So if we take the composition function which implies h of g of f, h of g of f, look at here, g of f, g of f, g of f, g of f from A to C, g of f A to C. So h of this is from A to D. This is a function from A to D, and f is a function from A to B, and your h of g is a function from h of g is a function from B to D. So if we take the composition of these two, first take this h of g of f. H of g of f is a function from A to D. So look at here, h of g of f and h of g of f. These two functions are from A to D. That means from same set to same set. पहले शो कर दे कि these two functions exists under same domain and codomain. The two composition functions exist under same domain and codomain. Now to show the two functions are equal. So let A belongs to A. Suppose A is an element of A set, and we have to show h of g of f of A is equal to h of g of f of A. At this point A, the two functions are equal. At this point, if the value of these two functions are equal, then the two functions will be equal. So now h of g of f of A is equal to h of, this is g of f of A, which is equal to h of g of f means g of f of A, which is equal to h of g, this is h of g of f of A is equal to h of g of f of A. So h of g of f is equal to h of g of f. Hence proved. So the composition function is associative but not commutative in general. Another important property, if f is a function from x to y and g is a function from y to z are onto, if these two functions are onto, then the composition function GOF is onto. If two functions are onto, then GOF is onto. The composition function GOF is onto. So given f is a function from x to y is onto, g is a function from y to z is onto, and to show the composition function is onto. Now look at here, if f is onto, that means onto function means every element of y has at least one pre-image in x. Every element of y has image in f. That means here, according to definition of onto, range of f is y. That means range f means f of x set, हर एक एलिमेंट का इमेज इज y. Also g is onto, that means range of g is z. onto means every element of z का हर एक एलिमेंट का प्री इमेज रहेगा. तो range of g is z set. Range of g means g of y is z. Now we have to show GOF is onto. GOF is onto means the range of GOF should be equal to codomain of GOF. Now g of f of x is equal to g of f of x. G of f of x is here y, g of y, and g of y is z. So we find g of f of x is equal to z, but this is the range of GOF function which is z. So GOF is onto. Next property, if f and g are 1 1, then so GOF is 1 1. If the two functions are 1 1, then GOF is 1 1. Now here f is a function from x to y is 1 1. If 1 1, according to the condition of 1 1, for f of x1 is equal to f of x2 implies x1 is equal to x2. g is also 1 1. That means for if g of y1 is equal to g of y2, then y1 is equal to y2. But we want to show GOF is 1 1. That means we have to take GOF of x1 is equal to GOF of x2. G of f of x1 is equal to g of f of x2. Let GOF x1 is equal to GOF x2. So to show x1 is equal to x2, if we can find x1 is equal to x2, then this is 1 1 function, which implies this is g of f of x1 is equal to g of f of x2. F of x1 is equal to f of x2, which implies if f of x1 is equal to f of x2, x1 is equal to x2. So GOF x1 is equal to GOF x2 implies x1 is equal to x2. Hence this function GOF is 1 1. Another property, if f is a function from x to y and g is a function from y to z, if g of f is onto, then g is onto. Given f is a function from x to y and g is a function from y to z, so we can write f of x is equal to y and g of y is equal to z. We have to take GOF is onto and to show g is onto. Let GOF is onto. If GOF is onto, according to the definition of onto means every element of a codomain has at least one pre-image in its domain set. That means if GOF is onto, GOF का कोडोमेन है z, z सेट का एवरी एलिमेंट का प्री इमेज एक सेट में है. सपोज z इज एन एलिमेंट ऑफ z सेट. सो फॉर दिस z there exist, this is the symbol of there exists x belongs to x. हर एक z के लिए x होगा. For which g of f of x is equal to z. Now g of f of x is equal to z, which implies g of f of x is y. So g of f of x means g of y is equal to z. So g of y is equal to z means for every z belongs to z, there exists y belongs to y. Every element of z is associated with one element of y. That means g फंक्शन के लिए इसका कोडोमेन का हर एक एलिमेंट का प्री इमेज y सेट में है. सो g is onto. Another property, let f is a function from x to y and g is a function from y to z. If GOF is 1 1, then f is 1 1. इसका प्रीवियस प्रॉपर्टी था if composition function GOF is onto, then the function g is onto. पहला वाला फंक्शन onto होगा, but here is GOF is 1 1, the second वाला फंक्शन f is 1 1. So how can you show? Given f is a function from x to y, if f is a function from x to y, then f of x is equal to y. G is a function from y to z, so g of y is equal to z. We want to show f is 1 1. So this will be proved by contradiction method. Contradiction method क्या है? देखो, हमारा प्रूव करना है f is 1 1. हम लेंगे क्या? सपोज f is not 1 1. Contradiction method means, understand the students, सपोज हमको प्रूव करना है this is chalk, this is chalk. हम क्या लेंगे? सपोज this is not chalk, this is not a chalk. दिस इज नॉट ए चॉक हम लेंगे. देखो प्रूव करना है दिस इज ए चॉक, हम क्या लेंगे? दिस इज नॉट ए चॉक. प्रूव करना है दिस इज ए चॉक, ये चॉक है, हम प्रूव करेंगे. हम लेंगे क्या? दिस इज नॉट ए चॉक. एंड हम प्रॉब्लम आगे बढ़ाएंगे, कंटिन्यू करेंगे. लास्ट में अगर हमारा बात सही निकला तो हमारा बात क्या था? ये चॉक नहीं है, सो दिस इज नॉट ए चॉक. अगर हमारा बात गलत निकला, रॉन्ग हो गया, देन हम क्या बोले थे? दिस इज नॉट ए चॉक. अगर हमारा बात गलत निकला तो ये चॉक नहीं है, गलत है. तो सही क्या है? ये चॉक है. दिस इज द मेथड ऑफ कंट्राडिक्शन. कंट्राडिक्शन मेथड मीन्स तुमको जो प्रूव करना है उसका नेगेटिव चूज करो और आखिर में शो कर दो कि ये फॉल्स है. सो लुक एट हियर, हमको यहाँ शो करना है f इज 1 1. लेट f इज नॉट 1 1. सपोज f 1 1 नहीं है. सो इफ f इज नॉट 1 1, 1 1 का कंडीशन क्या है? 1 1 का कंडीशन है फॉर x1 इज इक्वल x2, देन f of x1 is equal to f of x2. This is the condition. But if this is not, This is the condition of 1 1 function, but we take this is not 1 1. That means for x1 not equal to x2, f of x1 is equal to f of x2, implies we take g on both sides. G of f of x1 is equal to g of f of x2, and which implies g of f means this is g of x1 is equal to g of f of x2. So which implies, but we have given the composition function is 1 1. If g of function is 1 1, so g of f x1 is equal to g of f x2 implies x1 is equal to x2. But हम assume किए थे x1 is not equal to x2, और we find x1 is equal to x2. So this is false. If this is false, then हम जो assume किए थे वो false हो गया. हम क्या assume किए थे? f is not 1 1, which implies f is 1 1. Another important property, f is a function from x to y, then f of I of x, the composition function of a function with the identity function on x, is equal to the function f itself, and the composition function of identity function on y set of f is the f itself. Now first, so here we have f is a function from x to y. If f is a function from x to y, then f of x is y, and we know identity function on x, ix is identity function on x. So a function is on x means from x to x. So ix is a function from x to x. That means ix of x is equal to x set. Look at here, ix is a function from x to x, f is a function from x to y. If we take the composition function f of ix, then this will be a function from x to y. This is the composition function f of ix. So this is a function from x to y. Now we want to show f of ix is equal to f. Now for x belongs to x, suppose we take an element x of x, f of ix of x is equal to f of, this is ix of x, which implies f of ix of x is x, and this is f of x is equal to y, is equal to f of x. So we find f of ix of x is equal to f of x, and f of ix is equal to f. Similarly, second also we can prove. Next property is, if f is a function from x to y and g is a function from y to x. Look at here, the interesting thing is, this is x set, this is y set. F is a function from x to y and g is a function from y to x. So g of f, g of function is from x to x. So if g of f is a function from x to x, then x to x means identity function on x. So if f is a function from x to y and g, so g of f is a function from x to x means x to x means on x, mean identity function. G of f is a function from x to x means on x, means identity function on x. So f is a function from x to y, g is a function from y to x, be two functions. Then g of f is a function which is known as the identity function on x. Then f is injective and g is surjective. Second is, if f is a function from x to y, g is a function from y to x, same, be two functions, such that f of g is iy, means identity function on y. Then in this case, f is surjective and g is injective. Property 11, if g of f from x to z is onto the, if the composition function is onto and g function is 1 1, then the next function is onto. If the composition function is onto and g is 1 1, then f is onto. And the 12th property is if g of f from x to z is 1 1, if the composition function is 1 1 and f is onto, then g is 1 1. So look at here, if the composition function is onto and the g function is 1 1, there is f is onto and the composition function is 1 1 and f is onto, then g is 1 1. So these are the properties of composition functions. Now is inverse of a function is a very important part of a function chapter. How can we find the inverse of function? I find when the inverse of a function exists. We have already learned the different types of functions, and in that chapter I have already said when we can find the inverse of function. Look at here, f is a function from x to y. If f is a function from x to y, then there is possibility of a function from y to x. But dear students, if f is a relation from x to y, then there must be a relation from y to x, because every relation has a inverse relation, but every function has not inverse function. The inverse of every function doesn't exist. Inverse of every relation exists, but inverse of every function doesn't exist. So if f is a function from x to y, from y to x is the inverse of f. But when if f is a function from x to y is a bijective function, then f inverse exists. Then the students, the inverse of a bijective function exists. If a function is not bijective, then we cannot find the inverse of a function. The only condition for the existence of inverse is that the function should be bijective. So if f is bijective function, then f inverse exists. And if this f is a function from x to y, then the inverse is from y to x. Look at here, if f is a function from x to y, x is related with y, that means the image of x is y, and this y is f image of x. This y is f image of x. So we write y is equal to f of x. Y is f of x. But if f inverse exists, f inverse is also a function. If f inverse is a function, then this x is also f inverse image of y. Y is image of x for this function. X is image of y for this function. So y is equal to f of x and x is equal to f inverse y. X is f inverse y. So dear students, when f is a function from x to y, we write f of x is equal to y. And if f inverse is a function, if f inverse exists, then we write f inverse of y is equal to x. So if f of x is equal to y, then x is equal to f inverse y. So recall this, if f of x is equal to y implies this x is equal to f inverse y. So this is the notation of inverse function. So remind the students, if a function is bijective, both 1 1 and onto, both surjective and injective, then the inverse of a function can exist. If a function is not bijective, then its inverse does not exist. We can define inverse function in another way. This is another definition of inverse function. How? F is a function from x to y. Then there exists a function g from y to x. Suppose we have f is a function from x to y and g is a function from y to x, but I have shown here g is a function from y to x, but this x is actually this set. ये दोनों समान है. तो look at here, what happens? Composition function g of f is a function from x to x. That means here g of f is a function from x to x. That means if we take g here, so composition function g of f from x to x. This g of f is a function from x to x. From x to x means this is a function on x. So on x means identity function on x. So this is identity function on x. Similarly, f of g is a function from y to y. That means f of g is an identity function on y. So for f a function from x to y, if you can find a function g from y to x, then we can say, look at here, this g is, if you can find g from y to x such that g of f is identity function on x and f of g is identity function on y, if g satisfy these two conditions, then we can say this g is inverse of f. So g is inverse of f implies f inverse is equal to g. F inverse is equal to g. This is another definition of inverse function. F is a function from x to y. If f is bijective, then f inverse is a function from y to x. F is a function from x to y. If f is bijective, then f inverse exists. To show f inverse is a function from y to x. In order to show f inverse is a function from y to x, first we have to show domain of this f inverse is y set. Second is, for every element of y must have an image here. That means every element y belongs to y must have unique image in x set. This is the condition of this is the definition of a function. So first is to show domain of f inverse is y. We have f is bijective, means f is surjective and injective. So as f is surjective, if f is surjective, every element of y must have one pre-image in x. So for every y belongs to y, there exists x belongs to x. For every y there is a x here. So हर y के लिए एक x है, that means x and y are related. x y belongs to f. If x y belongs to f, then y x belongs to f inverse. So if y x belongs to f inverse, but we know the set of first component is the domain set. So that means y belongs to the domain of f inverse. But y was element of y set. y पहले y set का एलिमेंट था. अब दिस y डोमेन ऑफ f इनवर्स का एलिमेंट हो गया. दैट मीन्स y सेट का हर एलिमेंट इस सेट में है. अगर एक सेट का हर एलिमेंट दूसरा सेट में है तो y इज द सबसेट ऑफ दिस. y इज द सबसेट ऑफ दिस. अगेन बट क्या होता है, f इनवर्स इज फ्रॉम y टू x. दैट मीन्स f इनवर्स का डोमेन में y सेट से ज़्यादा एलिमेंट नहीं रह सकते. दैट मीन्स डोमेन ऑफ दिस f इनवर्स मस्ट बी सबसेट ऑफ y. y सेट से बाहर तो हम नहीं ले सकते. सो डोमेन ऑफ दिस इज सबसेट ऑफ y. लुक एट हियर, y इज द सबसेट ऑफ डोमेन इनवर्स. y इज द सबसेट ऑफ डोमेन ऑफ f इनवर्स एंड डोमेन ऑफ f इनवर्स सबसेट ऑफ y. तो a सबसेट b subset A. So these two are equal. So first condition, domain of f inverse is y is proved. Second, so for every y belongs to y has unique image in x. And the question is, f is a function from R to R given by f of x equal to 3x plus 5. f of x is equal to 3x plus 5 and we want to test whether the inverse exists or not. In order to test the existence of a inverse of a function, first we have to show, we know that if a function is bijective, then its inverse exists. So in order to test a function is bijective, we have to show its surjective and it is injective. So first we test its injective. f of x1 is equal to f of x2. फर्स्ट हम f of x1 is equal to f of x2 लेंगे और टू शो x1 is equal to x2, which implies f of x1 है. लुक एट हियर, f of x is equal to 3x plus 5. सो f of x1 कितना होगा, 3x1 plus 5 is equal to f of x2 कितना, 3x2 plus 5, which implies अब 5 कैंसिल हो गया. 3x1 is equal to 3x2 implies x1 is equal to x2. So f is 1 1. Next, show f is on 2. In order to show f is on 2, take f of x is equal to 3x plus 5. Take it as y, which implies 3x is equal to y minus 5, which implies x is equal to y minus 5 by 3. So मैं पहले भी बता चुका था कैसे टेस्ट करेंगे. x is equal to y minus 5 by 3. Now y belongs to R because the codomain is R and y belongs to R implies y minus 5 by 3 belongs to R. Real number minus 5 is real number by real number is real number. So which implies if y belongs to R and y minus 5 by 3 belongs to R implies this y minus 5 by 3 is equal to x. x belongs to R. So what happens? For every y belongs to R, there exists x belongs to R such that f of x is equal to f of x means y minus 5 by 3 is equal to, put here 3 into f of x is here, x is y minus 5 by 3 plus 5, and if we solve this, this is y. So f of x y, hence if f of x is equal y means every y का प्रीमेज है, that means f is onto. So f is 1 1, f is onto, that means this f is bijective. If this f is bijective, then f inverse exists, and if f inverse exists, then f is invertible. So पहले हम टेस्ट कर दे कि this function is invertible, means इसका inverse exist करता है. So how can you find what is the inverse? What is the value of inverse? In order to find inverse, you have to take f of x is equal to 3x plus 5 is equal to y. When you are evaluating a function, you have to find the value of y. But when you are calculating the inverse, when you are determining the inverse of a function, you have to find the value of x, because we know if f of x is equal to y, x is equal to f inverse y. So for function, find the value of y. For inverse, find the value of x. So from this, x is equal to y minus 5 by 3, and this is f inverse y, which implies if f inverse y is this, then f inverse x is equal to x minus 5 by 3. So if f of x is equal to 3x plus 5, then its inverse exists, and the inverse of this f inverse x is x minus 5 by 3. But another additional question is to find f inverse 1, and f inverse 1 is put 1 in place of x, 1 minus 5 by 3, and this is minus 4 by 3. Similarly, you can find f inverse 0. Look at here, f is a function from x to y, is bijective, then f inverse of f is equal to identity function on x, and f of f inverse is equal to identity function on y. इसको हम प्रूव करना है. So to show f inverse of f is equal to identity function on x for all x in the domain set, let y is equal to f inverse of x. This is composition function. F inverse of x means f inverse of f of x, which implies, look at here, when y is equal to f of x, that means x and y, x is related with y, that means x and y belongs to f. So y is equal to f of x means x y belongs to f. So y is equal to f of x. So this x y belongs to f inverse, f of x and y belongs to f inverse, which implies if f of x y belongs to f inverse, then y f of x a b belongs to f inverse, b a belongs to f. So y f of x belongs to f. So if y f of x belongs to y, that means y is related with f of x, that means this f of x is a function of y, f of x is equal to f of y. If f of x is equal to f of y, then x is equal to y, because f is bijective, bijective means 1 1, f of x is equal to f of y means x is equal to y, as f is 1 1. So we have y is equal to f inverse of x, but f inverse of x we find it as x. So y is equal to f inverse of x, which implies y is equal to f inverse of x is equal to y is equal to x. So this is equal to x, and x is identity function on x. So f inverse of f is equal to identity function on x. Similarly, we can prove f of f inverse is equal to identity function on y. Some properties of inverse of a function: if f and g are two bijective functions, then g of f of inverse of g of f, inverse of g of is f inverse of g inverse. This is the important property. And next is the inverse of a function is always unique. The inverse of function always unique. That means a function has not more than one inverse functions. Third is the inverse of function is bijective function. The inverse of a bijective function is bijective. If a function is bijective, then its inverse exists and is automatically the inverse of a bijective function is bijective. Fourth is the inverse of inverse is the function itself. That means inverse of f inverse is the f function itself. If f is a function from x to y and g is a function from y to z, suppose a is a subset of z, then inverse of a GOP at a is equal to f inverse of g inverse of a. These are the properties of inverse of a function. Hope you enjoy a lot and thanks.